Hello, this is Mr. Coates, and this is APES lecture number 51 on supplies of fresh water. The goal of this lecture is to look at the pros and cons of where we get our freshwater resources. If you look down at this picture, this is the Hillsborough County Reservoir, and this stores most of the fresh water that we need for drinking and agricultural use in the county. And this is in South County. It's a fairly large reservoir, but it gets its water from groundwater and also from the Alafia River, as well as some desal, and we'll talk about that in a minute. So we need to increase supplies of fresh water. If you saw that map on the previous lecture, it looked like most of the United States was using too much fresh water. So somehow we need to increase the supplies. So we can do that several different ways. We can build dams and reservoirs to increase runoff collection. We could bring surface water from other areas, and we'll talk about a very important case study at the end of this lecture about that. We can remove it from the groundwater, and this is where most of your water comes from here in Hillsborough County. We could also convert salt water to fresh water, and some of your water that you drink also comes from this. However, the best way to increase our supply of fresh water is to improve efficiency, and we'll look at that a little bit later. I want to draw your attention to this down here, this picture down here. This is the inside of our desal plant here in Tampa Bay. Tampa Bay actually has the largest desalinization plant in the United States. And it takes water out of Tampa Bay and removes the salt through what we call reverse osmosis, and then adds that fresh water to our water supply. And these are all the reverse osmosis filters in that plant. And we'll talk about that plant a little bit later, but I wanted to show you what the inside of this plant looks like. Now, one of our first important sources we're going to look at is groundwater. Groundwater comes from aquifers. Remember that an aquifer is a porous section of earth underneath the ground. It can be deep, it can be shallow, and all the pore spaces between the soil particles or within the rock contain or are saturated with water, and that's what an aquifer is. Now, there are certain parts of an aquifer we need to talk about. First of all, we have the water table. The water table is the line at which the aquifer comes up to within the soil. And so this is the water table in this area here. So that's the top of the saturation zone. Now above that is the zone of infiltration where water seeps down to the aquifer, and it's also known as the zone of aeration. In this zone, the pore space between the soil is not totally saturated with water. Now below that then is the zone of saturation. And so in this area here we have water that is saturated with pore spaces, and this is known as our aquifer. Now in Florida we have one major aquifer. It's called the Floridan aquifer, and it stretches all the way up into Georgia and to South Carolina. And so this is the Floridan aquifer in most of the state here, except for this little bit, the south part. And that's where we get most of our groundwater, and it usually starts getting into the ground up in the Appalachian Mountains up in this area, and then slowly flows underground southwards into Florida. Also, there are ponds and lakes and streams that will slowly infiltrate into our aquifer here, but a lot of it comes from outside of Florida. Now, there are other types of aquifers out there. There are two different types you need to know about. First one is called an unconfined aquifer. An unconfined aquifer is one that is directly connected to a lake or a stream. So as the lake fills up, the water slowly infiltrates into the ground, and this is called an unconfined aquifer. Now, the second type is a confined aquifer. A confined aquifer has a layer of unporous rock or soil, maybe like clay, that keeps water from seeping down into it. And this is called a confined aquifer because it does not intermix with the surface water like the unconfined aquifer does. So there's an area of recharge where the water gets into this confined aquifer, but it does not mix with the unconfined aquifer water. This is usually a very slow-flowing aquifer. It doesn't move a whole lot, and the water is fairly clean at this point. Now, there are some pros and cons of using groundwater for human use. One of the first pros is that groundwater is available almost everywhere on the planet, and so if you can drill deep enough, you can usually get to fresh water. The other thing is that this water is usually in pretty good shape for drinking and irrigation. In fact, usually you don't have to do too much to it if you get it deep enough to drink it. It usually doesn't have any kind of contaminants. It's usually fairly clean. It's clear typically, and you really don't need to do a whole lot to it when you drink it. I grew up on a farm in Missouri, and we had a well on the farm where we got all of our drinking water, and we had no filtration on it whatsoever. And for the most part, it was very good water. It was clean. It was actually some of the best water I've ever had. Usually aquifer water is fairly clean. Also, if you don't overpump the aquifer, it's fairly renewable. So this is a sustainable source of water as long as you don't overpump it. Now, there are some cons to using aquifer water. One of those that we see here in Florida quite a lot is land subsidence. This means when the land starts to sink, when we take water out of the earth and the earth starts to compact in the aquifer, then we call that land subsidence. If you get a severe abrupt subsidence, we call that a sinkhole. And we see that quite a bit here in Florida. We've had quite a few sinkholes this year, and it happens whenever the groundwater changes levels, and this can happen due to overpumping. Also, aquifers can get polluted. Water that is contaminated with all kinds of hydrocarbons and other things can stay in the aquifer for thousands of years. It's very difficult to clean an aquifer once it is polluted. So you want to make sure that any aquifer you drill down to for drinking water doesn't have any contaminants in it. You can also get what we call saltwater intrusion, especially in coastal areas. This graphic over here shows you some saltwater intrusion. We have a well here that pipes down into this subfluoridated confining unit of groundwater here, and pumping water out all the time. And as this happens, this gets empty of fresh water, and salt water from the Atlantic Ocean or from the Gulf starts to seep in. And salt water's heavier, so it'll start to fill up the bottom here, and you'll start to actually move salt water up in this area and eventually get it into your pumping. And this is called saltwater intrusion, and it happens in places near the coast. And also, I mentioned that aquifers can be overpumped. We're going to look at an important case study about that here in a minute. We've also talked about dams. Dams have a lot of pros and cons. For example, pros can be water resources for humans. When we dam up a river and create a reservoir, that's a long-term storage reservoir for human use. And as long as that river continues to recharge that reservoir, we can use it sustainably. It also produces clean electricity, and it can also slow flood waters. If you get a flooding event upstream of the dam and reservoir can usually slow down the impact and mitigate the impact of that flood event. Now, there are some cons, and we've talked about these as well. The cons are it stops the normal water flow, so you get sedimentation in the upper part of the basin. And if we look at, this is Glen Canyon Dam here, and this is Lake Powell. What happens is the Colorado River flows down through here, and they dammed it up, so all the sediment that flows in from the Colorado River and the upper part of the reservoir here gets dumped. So the water in here is fairly clear. And the dam then discharges this water into the rest of the Colorado River, which eventually goes into the Grand Canyon there. We can also flood uplands. Obviously, before this dam was built, there are all kinds of upland areas that weren't flooded. There was an actual canyon up here called Glen Canyon, which is now flooded. That habitat and that cultural resource of that canyon is lost now because of the flooding. It also disrupts any kind of fish migration. If we have any kind of fish that migrate upstream, then this dam gets in the way, and a lot of times they have to build fish ladders around these dams in order for the fish to continue on their migration route. And then, of course, maintenance. Once you build one of these things, it continually has to be maintained. Water continuously wants to break the dam and erode it away, and you have to keep on maintaining the dam, so it's very costly. Down here is the Three Gorges Dam, and we've already talked a lot about Three Gorges Dam in China. It is the largest dam in the world. Now, one of the important case studies that I want to talk about is the Colorado River. We just looked at the dam that backs up the Colorado River north of the Grand Canyon. So we're going to look at how that dam affects the Colorado River, and then also what the Colorado River is used for. So this is a picture I took when I was in the Grand Canyon here. This is looking upstream of the Colorado River here. And you notice the river is very muddy at this point. There's a lot of small tributaries that come into the Colorado River, and they bring a lot of mud, especially in the rainy season. And so this is down here, a cross-section of Glen Canyon Dam. And if you look at the dam, it actually takes most of its water from a lower level of the reservoir. And this lower part of the reservoir, it's about 300 feet deep, and it takes very cold water. Now, this water is right around about 40 degrees when it comes out of here and empties into the Colorado River. Historically, the river temperature was right around 75, almost 80 degrees before they built the dam. But when they built the dam, this reservoir then, the cold water sinks to the bottom, and they take the water from the bottom to run the turbine, and it releases cold water downstream. Now they are trying to revise the way they remove water so they can up the temperature a little bit in the river, so they are starting to take some of the upper water that's warmer and mix it with the colder water, but they still can't take water very high up in the reservoir. So the water's still pretty cold coming out of the dam, and this has significantly changed the habitat of the Colorado River. Another thing that the dam has done is prevented flooding events. Typically the Colorado River flooded very heavily once every year. And the flooding event would basically wipe out all of this vegetation in these sandy bar areas. And it would also get rid of these sandy bar areas. And this was a natural phenomenon, and a lot of the fish species that relied on the Colorado River relied on this temporary flooding. And I mentioned that this vegetation was in this area, and it's mostly all exotic vegetation. It's vegetation that doesn't normally found in the Grand Canyon. Without that periodic flooding, this vegetation sticks around and reproduces, and it's starting to take over a lot of these sandy beaches in the Grand Canyon. So the Colorado River goes through about 8 states, and for legal reasons, the river basin has been divided up into an upper basin and a lower basin. And like I said, these 8 states then use this water, and it's been portioned out, so each state is allowed so much water use from the Colorado River. Now currently the system works a little bit, but however most of these states are taking more water out of the river than they're allowed to by this plan. And so 80% of the water is used for irrigation. Unfortunately, by the time the Colorado River reaches Mexico and empties into the Gulf of California, there's hardly any fresh water coming out of the Colorado River. In fact, the estuary that is in Mexico that the Colorado used to dump into is usually dry at this point. And Mexico has a huge problem with the United States taking all the water out of the river before it even gets to Mexico. It used to be a very important water resource for Mexico. But we also piped this water all over the Southwest, and we piped it as far as California and San Francisco. The city of Phoenix uses it, and unfortunately the efficiency of these transfer conduits like canals and pipes is not very efficient, and they leak a lot. And so if we could just improve the efficiency about 10%, then we would save quite a lot of fresh water. So this is a look at the actual watershed of the Colorado River, and you see the upper basin, which is up here, and that's Wyoming, Colorado, and Utah, as well as some of New Mexico. And then the lower basin, which is part of New Mexico, mostly Arizona, some of Nevada, and some of California. And so the river starts over here by Denver, and this is the longest fork of it. And it goes through Lake Powell, past the Glen Canyon Dam, which I just showed you, through the Grand Canyon, which is all this area here, and then to Lake Mead, which is right outside Las Vegas and is the main water source for the city of Las Vegas. And then it goes through, this is the Hoover Dam, and then it continues to flow. It goes through a few more dams, and then finally goes into Mexico. And like I said, by the time it gets down here, most of the water is gone. These 8 states really need the water from the Colorado River because they're in the desert Southwest. And in order to get their water, they have created all these aqueducts and canals. So City of Phoenix actually gets their water from this dam area, and the City of Palm Springs as well, and then also goes all the way over to Los Angeles, down to San Diego. So these aqueducts or canals move water from the Colorado River all across the desert Southwest. Here's another look at it. This is the California Water Project. Once again, the Colorado River is in this area here. And once again, we have aqueducts that take this water all the way over into the San Joaquin Valley, which is a huge agricultural zone. So most of this water is for agriculture, all the way almost up to San Francisco. And like I said, LA gets most of its water from the Colorado, as well as San Diego, Phoenix, and Tucson as well. And so this river is used very heavily. And unfortunately, because of all of our use, it just doesn't make it down to Mexico anymore. Now another way you can get fresh water is turning salt water into fresh water. We call this desalinization. Desalination can happen 2 ways. First, it can happen with the membrane, or RO, reverse osmosis. The other way it can happen with distillation, with heat. Now both of these are costly. It takes a lot of energy to push water backwards through a membrane. It also takes a lot of energy to produce the heat for distillation. And it produces a very salty wastewater. This wastewater then has to be discharged back out into the water body. And depending on the surface currents of that water body, the salt can stick around. That was one of the biggest debates here in Tampa Bay when we set up our saltwater plant, which is this one right here. This is the desal plant. This is the Tico power plant there off of Apollo Beach down here. They discharge right back out into Tampa Bay. And so they put a much saltier water into Tampa Bay. And there was a lot of debate before this plant went in about what the impact was going to be. So far, there hasn't been any noticeable impact, but it's only been up and running full steam for a couple of years now, and so we don't know. The other country that uses desal quite a lot is Saudi Arabia. In fact, most of Saudi Arabia's fresh water does come from desalinization of ocean waters around Saudi Arabia. It's a desert country. It doesn't have a whole lot of groundwater, and about its only source of fresh water is to take the salt out of the seawater. Well, I hope that answers some questions about what we do with some of our freshwater resources and some of the pros and cons associated with those. Make sure you know those pros and cons. If you have any questions, please bring them to class.